Newton's first and second laws state that in order for an object to change its velocity, a force must be applied. We will demonstrate two cases of this happening in an unnatural but accurate simulation.
The first part of the demonstration shows Newton's law is when I hit the ball. Since we're only focusing on the horizontal component of the ball's travel, we can say the part where she tosses the ball into the air is not needed, just focusing on the x-axis. The ball has an acceleration of 0 and really a velocity of 0 at the beginning of the swing. When the bat actually makes contact with the ball begins moving towards John, and the ball is able to travel forwards due to the fact that the bat is a greater mass, and so the ball cannot counteract the force the bat is applying on it and thus has nowhere to go but away from the bat. Using the equation F equals ma, one can see that the ball has a relatively small mass and no horizontal acceleration, leading to a small force on the bat, where the bat has a pretty large mass compared to the ball and a big acceleration, leading to the ball being able to accelerate off the bat.
The second part of the demonstration occurs when the ball hits my head. Now we will be focusing on the vertical component of the ball's trajectory. The ball has a certain velocity falling down, and when it hits my head, it bounces upwards. This is due to the fact that when the ball hits my head, a normal force is applied to the ball, preventing it from going through me. Just like with the bat, the ball can't just stop and lose its downward velocity instantly, so it is pushed up by my head and thus bounces away. One can also use the equation F equals ma to explain how this is possible. The ball, again, has a small mass compared to me and a pretty big acceleration downwards, leading to a moderate force. I, on the other hand, have no vertical acceleration, but a large mass, leading to a larger force than the ball because I have so much greater of a mass than the ball, and it provides me with a much greater force.